Yo, alright. This is the first time ever doing this. Let's do a first time ever doing a study stream. Got my cereal. Alright. As a resource allocator. Where's my book at? Let me get my dictionary. Arbitrates. Conflicting slash competing request for shared resources. Okay. Operating system is a control program, allows multiple programs to run without interference, restricts access allowed to shared resources. Just I saw a unique YouTube pop up on my feed about this exact same thing. Like they're trying to determine like when the operating system ends and when the kernel begins. Because I feel like a lot of times people just say it's kind of like I feel like that whole concept is confusing. I might need to do a reaction to that YouTube channel or that YouTube video because that shit is kind of confusing sometimes. Because most people refer to Linux as like an operating system, but then you'll have that one person be like, actually, it's the kernel. Abstract view. User 1, User 2, User 3, computer hardware, operating system programs. Can you think of any common devices that don't have an operating system? How might that affect their functionality? I mean, probably like a calculator, I guess. Like a basic one. CPU modes define privilege levels that control what a program can do. Okay, let me see. Got kernel mode. The OS has unrestricted access to hardware and resources. And you have user mode. Apps run with limited privileges. Ensuring integrity. Computer starts in kernel mode to set up the system, initialize hardware to a known state, load the OS. Applications are started in user mode to isolate them. Okay. That's important. Let me jot that down. I look you want some coffee. I might make some. Well, I'll do that once I get to like the second presentation. Mode transitions use interrupts and traps. Okay. Hold on, let me check my dictionary. Let's see if that's in here. I'm pretty sure interrupt just means canceling a process. Let's see. Input, insertion, integer, Intel, inner block, interlacing, interactive system, internal. Okay. Interrupt. Okay. Yeah, it is. Okay. Hold on. We can put the definition down for that. Interrupt. An interrupt is an instruction that tells a microprocessor to put aside what it is doing and call a specified routine. The processor resumes its original work when the interrupt service routine finishes. Okay. Mode transitions use interrupts and traps. So between the user mode and the kernel mode, it will use an interrupt or a trap. And traps. Let me go ahead and put like a footnote for interrupt. Was it an instruction that tells the microprocessor to stop doing what it's doing? Okay. Okay. And do we have a definition for a trap in this? Japanese writing. What? Why is that in here? No, it might not. We might have to look that up ourselves. Trackball, tractor feed, transistor, transparent, trapping. Okay, here we go. To trap an event is to perform a special action when something happens that would ordinarily interrupt the operation of the computer. For instance, some programming languages provide error trapping, which means that when the program attempts to do something impossible, such as divide by zero or read a file that doesn't exist, control will be transferred to an error handling routine supplied by the programmer. If no error trapping were provided, the programming would simply end with an error message that might puzzle the user. In BASIC, Trapping is activated by statements such as an on error. Okay, I think I get it. But what's the difference? The trapping event. Okay, I guess it's like an if statement. If something happens, to stop it, like to terminate it. Where an interrupt is like is an instruction instead, and a trap is an event. But does like a trap ever go back, or is it just like completely terminated? I'm guessing the difference is like an interrupt will stop the process and then eventually run it again, whereas a trap is will just completely like stop the process completely. I don't know. I have to look that up, I guess. These transitions raise the CPU's privilege level to kernel mode. Okay. So kernel mode. Control is handed to the OS. Once the OS services this event, the CPU switches back to user mode. Okay. Programming a computer used to take days of preparation. Okay. Gradually will automate these tasks. The dawn of computing, 1940s to 1950s. Look at them bad boys. Oh my god. Had to do this when you had to do it manually, huh? Like you had to manually do shit. One user, one program took days to set up. Very expensive hardware, inefficient use. Programs were entered via switches or rewiring. Later, we stored programs on punch cards and tape. Used tape. IBM 701 also used tape. The advent of multi-programming, the 1960s. They were using like what, floppy disk? Could have several programs loaded into memory at the same time and switch between them. Time sharing systems like CTSS and multi CS allowed multiple users to use the computer concurrently. Okay. So previously it was just like one user, one program. Now we can actually have multiple users using different programs concurrently. Expensive CPU time, slow IO, multiple programs loaded at the same time, sharing of resources. How do we switch programs? Much higher efficiency and utilization, possible for one program to interfere with another. How do we switch programs? Let me get this. We stop one program in a way that we can resume it later. I guess that's the interrupt. The program state must be completely restored. What defines a running program? The contents of memory, program, and data. CPU registers. Any values unique to a running program are saved in the kernel. Okay. Okay, let me jot that down. That seems important. To a running program. are saved in the kernel. We will study the process control block which each process has. Running programs can now interfere with each other. One program might overwrite the data of another program. Programs might hog the CPU and prevent others from running. Programs might try to use the same I/O devices at the same time. Interference can cause programs to behave unpredictably. It can also lead to programs accessing data they should not. Okay. That was like the intro. Now it's time to get to the actual meat and potato. Let's get into processes. And then after we can do some self-study for that. Processes. Let's jot some notes. In an independent unit of work, a process is a program in some state of execution. Independent unit of work. That's the definition of a process. Actually, let's look in my definition book. Let's see what this defines process as. Okay. Process. Hold on, wait, what is this? Okay. Process. In a multitasking computer system, each series of instructions that the computer is executing is called a process or a task. Process may be programs or parts of programs, such as the editing routine and the printing routine in a word processor that can print while editing in a multi-user operating system, such as Unix. Each user has one or more processes. Okay, so it's just like a task. What they find it as. A process in a program is some state of execution. Of execution. New, ready, running, waiting, terminated. Okay. A process is made up of several components. An address. Oh, this is important. An address space with the memory. Data the OS keeps on the running program. The PCB. What resources have been what resources have been allocated? Processes versus programs. Programs are a set of instructions to the computer. Programs are static entries. Executable files or programs, processes are in a state of a running program. Are in an instance. Are an instance. Are in an instance of a running program. Processes are dynamic. Information the OS stores for each process. The process control. Okay, so this is the PCB. The PCB process control block. The PCB. Information the OS stores for each process. The current state. The program counter. And the other registers. CPU scheduling information. There's a lot of stuff that it keeps track of, no cap. Memory management. Information. What memory is allocated? Okay. Accounting information. IO status. Open files. This is the stack, the heap, typical address space, the program instructions, initialize global variables, uninitialized global variables, pool of dynamically allocated memory, local variables, function, parameters, return address. I'm kind of confused looking at this. Example program. Integer x, integer y equals 15. Okay, these are local variables. Alright. Note that I include the section in the online manual with commands. System calls, library routines. Can we, hold on, let me see. Actually, let me not do tab. Let me do. I don't even have like the VPN, so I couldn't even do this. I need to get Cisco. Can I not? Hmm. I was like, there's no way I can just do that, right? Do I need a library? I forgot how you isn't it like how do I compile? How the fuck did I fuck up this shit? That's it, no? I need a library. What library? Well, obviously it doesn't. Oh. That's why. Maybe let's just fucking rename it then, bro. Fuck it. Actually, no, let's keep it. This is what I was looking for, bro. I needed a header. And they're like, no, bro. Trust. You don't trust. Whole time. I knew I needed a header. That's what I wanted you to do. Just give you the header. Which one is that? IO stream. So that should be good, right? So just want me. Okay. I guess I always gotta do this then. But just wanted a simple, like, come on, bro. Like, you're like, give me the wrong shit, bro. There we go. Alright, so then I could just do this now. Okay. What is this? Okay, but like, how do you use it? Like, it just says. Okay, let me see. Do I just put the file name? That? Okay. So command line used to display detailed information about executable and linkable format files. Oh, okay. It's for X. Okay. But then, is that just the port for like other things? So like, if I do read elf, like, let's see, ls. Is that Oh, so okay. There we go. Mhm, mhm, mhm. Oh, there it is. bio local name. That's a global. That's a global function. Oh, so it's just looking at the. Oh, okay. 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 Processes are created with a system call. System call. System call. System call. Unix uses the fork. System call to create a new process. An existing process. Most processes will be paused and resumed many times by the OS, allowing many processes to share the same computer resources. Processes may terminate by several mechanisms. Okay. Return from main. Use the exit system call. Receive a terminal slash fatal signal. These are the states, the process states. All right. Man, I really want that coffee. New. Being created. Address. Space. Setup. Process. ID assigned. But not assigned a CPU. So this is what you'll see in your task manager is like the running process. Okay. Instructions are being fetched. Slash executed. waiting. Process is blocked, waiting on event. Terminated. It's not been completely removed from the system. So when it gets interrupted, it goes to the ready process instead of the waiting. And an exit, it'll go to terminated. But if in an IO or wait, huh? So you can only go to waiting after it's been to running. And then waiting can go to ready. Or waiting does go to ready, so it doesn't even go to running. It's just waiting to ready and get back to running. Okay. Covered in more depth later. Process scheduling. Fuck, bro. This is like, this is good for me. This is good for me. Like, I think I've been way too. I gotta like. I'm tired. I'm bored. But I need this. I need this. I need this. I need this. I don't even got music playing. I can't even play music on stream. Like if I was just studying by myself, I'd be playing music or I'd be watching a YouTube video right now. Since I'm on stream, it's just straight. This is what you see. This is what you get. I think I need to do this more. I think I need to do this more often. Just fucking put myself in a situation where I'm just gonna bore myself. But I just made a video about this. Go watch it in pornography. So process of scheduling is goal is to maximize. Maximize CPU use. We have the process scheduler. You think that's a definition for that in my book of definitions? It's not underneath process, so let's go check if schedulers in here. Nope, it's not in here. Selection available, process, and assigns CPU. What process will run next? And for how long? Short period of time. I spelled that wrong. Referred as a quantum. Is that in my definition? No. What is this? This is the punch card, bro. This is what it looks like. It's actually in there. Okay. CPU is allocated for a short period of time, referred to as a quantum. Contains scheduling queues of processes. Processes. So you have the job list, which is a set of all processes. Ready list. Set of all processes in the ready state. And then device list. Is that like for the IO? Yep, looks like it. Processes waiting for a specific IO device. Processes migrate between queues as they change state. I'm just gonna refer to them as P, bro. Writing that shit out all the time is getting. It's turning out to be a fucking headache. Oh shit, I should have changed. Should have put this on another line. All right, as a change state. The PID. Okay. The OS will assign a process identifier. And we can actually check that. The initial address space is set up. Under Unix, a clone of the parent process. If requested, this address space can later be replaced. How processes are created. Okay. Okay. Process control block is created. Okay. Once it's created, it moves to the ready state. So this is like the new state, I'm assuming. Right? Hold on, let me look at my states again. This is the new state. So this is the new state. This all happens underneath the new state. And then we get to the ready state. Under Unix, fork creates a new process, duplicate of parents. Okay. Oh, okay. Execute replaces the memory of the current process with a new program. Replaces the memory of the current process with a new program. Oh shit. Okay, so when it okay. Okay. So when it it terminates and then it goes back it it merges back with the parent process or just basically ends and the parent process resumes. Okay, I see. A process may request termination by making the exit system call, returns the exit status to the parent via wait. Okay, so it return okay, so when it makes the exit call, it will return a status and that status will get turned to the wait and that's basically the signal for it to resume, for the parent to resume. Process in a zombie state until the exit status is read. Okay. And process resources are deallocated once status is read. A parent or privilege process may terminate a child process. Okay. Let me let me jot this. Yeah, my brain is fried. I'm not gonna lie. My brain is cooked. The fact that I'm so sleepy, just because I'm not like, bro. I need to get up. I need to get off. I need to get off. I need to go outside, bro. I need to go touch grass. Like, actually, I need to go touch grass, bro. Like, actually. Parent or privilege process may terminate a child process. Hold on, wait. My handwriting for child was low key peak. What the fuck? That I wish y'all could see that. That looks so good right now. Via the kill system call. We know that. We know what that is. Child may have exceeded. Okay, I spelled that wrong. Exceeded allocated resources. I didn't even know it could do that. Okay. No longer required. The parent is exiting. If all children terminated. That sounds crazy. Cascading termination. Let's look that up. I have cascaded windows. Cascaded windows look like a stack of cards with all but the top left edge of each card hidden by the one in front of it. When the windows on the screen are cascaded, you can see the title bar of every window. See the title bar. Okay. Just want to give me an idea of what that means. Bro, that TikTok is hilarious, bro. All right. All right, lock it. No, I took a little like 3 minute TikTok break. Not even 3 minutes, more like a minute. All right, let's log back in. Let's log back in. Let's log back in. Okay, let's log back in. Process management. Okay, parent process may wait for a child to complete execution. That's the wait and the wait. PID system calls. There's a wait and a wait PID. Oh, okay. So there's a traditional wait, and then there's the waiting for the process. Is that just waiting for the child process to end? I'm assuming. I don't know. Child may lower its priority. And what is that? That's a nice system call. Is it like a nice child? Is that what it is? That why it's called that? Nice child? Nice child system call. Parent may get slash set child process priorities. Get priority and set priority. Process may send signals to another process. Bro, how many fucking times have I yawned, bro? Like, how many times have I yawned in this live, bro? God. I need to do this more often, bro. I think tomorrow I'm gonna do the exact same thing. Like, I feel like I've been trying to get off TikTok. I've been trying to, like, fix my brain. I feel like my brain's too rotted. I need to, like, put all the distractions aside. Just fucking, no music, no YouTube, no TikTok. Just fucking sit down, pen and paper, bro. Pen and paper. Because right now, this shit feels like hell. And it really shouldn't feel like that. Like, it should feel like I should be used to this. I mean, I got my phone right here, but that's only to, like, look at so I can look at the chat. But there's, like, I'm the only person in it right now. Let me go ahead and give myself a like. I deserve it. Y'all see that? Y'all see that? That's all love. That's all love. That's self love right there. That's self love right there. And then let me finish writing this. I will be making coffee though. No cap. I need something to make sure I don't just fall asleep. What we got? All right. Let's move on. Next one. This next one. All right. Context switching. How can we appear to run multiple programs at once? We don't actually. It just switches really fast. I know the answer to that one. I know the answer. What is it? We don't have enough CPU cores for each process to have one. Process may take turns. This means that we must switch which process running on a core. Pause the running process, save its state, restore the state of another process, resume the new process. This is called a context switch. See, I told you. Which process is running? Okay. So what do I even define that as? Switching? I guess I'll just use those. Pause the running process. Save its state. Restore the state of another process. Resume the new process. Other words, switching really fast. So that it looks like they're all running concurrently, but they're actually just switching really fast that you can't tell the difference. We will cover scheduling in more detail later. Concurrency, parallelism. Multiple processes appear to run simultaneously. processes actually run simultaneously. So concurrently is just literally just like it's literally just fucking bait. Parallelism is the true simultaneously one. Modern operating systems use a technique called time sharing. The goal is to share the CPU with multiple processes. Is that why like C okay, hold on, wait. Let me look at it. Is that why the certain CPUs have that Intel core? Wait, so like if I say like an Intel Core i7 has like 7 cores, is that what that means? Okay, so the fuck is the i7 part stand for then? Like, then what the fuck is the 7? 3579 reflects performance levels. So wait, why not just put the fucking core? Like, okay, that's okay. Wow. So it's literally just for fucking advertisement. That's crazy. Because I got like an i5 right here. It's literally just advertisement. Okay. We can have many more processes and executing by sharing the core. With multiple cores, we can have both concurrency and parallelism. Okay, okay. I don't think I need to write that down. How do we pause, suspend a running process? You use an interrupt. The OS might regain control of the CPU core. An interrupt is the mechanism used to transfer. Okay, wait. So wait, the interrupt is the mechanism used to transfer control back to the operating system, and the operating system is the one that pauses and suspends the running process. Before starting slash resuming a process, our hardware timer is set. Okay. Okay, let me put that before. A hardware timer is set. Before starting or resuming a process, a hardware timer is set. When says if the timer expires, an interrupt will be generated. So that's not what a trap was, because that's what I thought a trap was. Interrupts elevate privileges and transfer control back to the operating system. So that is that the main difference between a fucking inter? Let me just ask. Let's see. Okay, that's the difference. Examples. Okay, so trap is triggered by like like system calls in the program itself, like read, write, divided by zero, software interrupt, or exception. Interrupts come from outside the CPU. Traps come from within. So that's why it elevates privileges back to the OS. Because if it's in the program, the OS is already doing it, I'm assuming. Oh, wrong thing. We will soon study a part of the kernel called a scheduler, which determines fine dispatcher return from the. Okay, wait. The scheduler informs the dispatcher of its decision. Dispatcher will save the state of the previously running process. It will load the state of the new process to run. Okay, bro. This is oh, bro. This is a lot. This is a lot. You know what's funny though is like a lot of this shit is just so like it's just so like real life. Like you're like a dispatcher. It's like something in real life. Like we just mimic everything in computer after real life. And then the dispatcher does everything. Like, okay. executing idle, save state into PCB, reload state from PCB. Fuck, I forgot what the PCB. I know it's the process control block, but I forgot like what the fuck the PCB does even does, bro. I should have it somewhere. PCB is created. Information the OS stores for each process. Okay, so the PCB is the information the OS stores for each process. So it stores the current state, the program counter, and the other registers, scheduling information, memory management info, accounting info, the input output states, and open files. Okay. And save state into PCB, reload state from PCB, interrupt our system call. Okay. That was processes. Made a few notes as I'm reviewing slides earlier and think they may be helpful as a study guide or posts because will appear in any form of the future exams, but I think they are essential information. Also note that exams cover all materials in the text and covered in class. That is obviously more than presented here, so questions are not limited to the following. What is a process? How does it differ from a program? Okay, so a process is a task. It's an individual task and is dynamic, whereas programs are static set of instructions. And processes are product are like I gotta go back to answer that better, but I think that's brief. What are the different states of a process briefly described? There's the new state, which is when it's being created. There's the ready state, in which it is basically in waiting, ready to run. And then there's the running state, which is the when it's retrieving instructions or it's currently executing instructions. There's the waiting state, which and when it gets hit with like it's it's either waiting or it gets hit with a waiting signal or it's like it gets interrupted with an input output device. And then once it gets into that state, it will go back into the ready state. And then there's the terminated state, which is basically the completed state. When do processes transition between these states? Okay, so the new state is when it's being created, so that's the first state. Ready state is when shit. I forgot what the ready state. Like it's not retrieving the instructions. It's not waiting either, but it's like signaling that it's ready to start. Like I guess that's the only way I can describe it. I really okay. Let me just skip it because I already did. What is the process control block and what type of information does it contain? Process control block is where the OS stores information about the process, and it will have information about the process state. It will have information about I just read this shit about input output devices, memory management, um, accounting information, open files. Um, I forgot what else. I don't know if that's all. Describe the typical steps involved in process creation. When a process is being created, it will fork. If it's a Unix, it'll fork and it'll duplicate the parent process, and then it will start a timer, a process timer. Fuck, I forgot. Let me see. New, okay, be, for the new being created address space setup process ID assigned. Okay, so the address space is being set up. The program is available to run but not assigned to CPU. This is like the states. But what was the what was like being created? The OS will assign a process identifier. The initial address space is set up. A PCB is created. Internal resource allocation may be made. Okay. What happens to a child process if its parent terminates before it does? And then it would also terminate and end. Yeah. What is a zombie process? How does the Unix Linux OS handle one? Well, zombie process is a state in which it is currently waiting for a signal. Otherwise, it's just sitting there idly doing nothing. And how does the Unix Linux OS handle one? I don't even know how to answer that. Like, I don't know. What is a context switch? And why is it necessary? Context switch is basically when the OS will stop a process, save its state, save its information, start a timer, and begin a new process. And it's necessarily to basically share resources between CPU cores. How did OS regain control of the CPU to perform a content? It uses the interrupt. What is the difference between concurrency and parallelism? Concurrency is where it seems like multiple processes are running simultaneously, or has the illusion of doing so, and parallelism is when it actually is doing that. What is the difference between user mode and kernel mode? User mode, but user mode is okay. Well, kernel mode is like elevated privileges for resource allocation, as well as certain system calls, whereas user mode is like, I don't know how to explain it. Like, there's less privileges to user mode. It's safer. Like, what is an address space? How is one created? How might a process completely replace its address space? Address space, shit. That's a good fucking question. That's a really good question. The address space is created by shit. How might a process completely replace its address space? I forgot. I have to. Let me look. An address space is a space within memory. Like, I mean, let me see. It should be somewhere over here. Just let me go back and see. No, that's not it. Fuck. Or no, these last two I'm definitely gonna need some sort of. Alright. Help me out. The CPU moderates in one of these two privileges levels at a time. Restricted execution environment for normal programs. Unrestricted execution for the operating system. Address space is a set of memory addresses a process is allowed to use. It's an abstraction. Okay. Process is created. Okay, so it uses fork, allocates page table, sets up the stack heap text data segments, replacing an address space. Oh, okay. So that's what that command was for. Right here. No, no, no. Right here. So this is it just replacing an address. Replaces okay, so no, it actually says right. Replaces the memory of a current process with a new program. So it just replaces the address space. So that's when you create a process, it does that. Duplicates the process, replaces its address with ls. Okay. Nice, 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 nice. I think I could do this. All right. Before we get to the second, what is it? We're gonna get to scheduling. Oh my lord. All right, yeah. I'm gonna go make some coffee for this. I'm gonna be back. All right. All right. All right. All right. I'm back. Let me go ahead and put this. Can y'all see that? Yeah, can't y'all? All right. I'm just gonna put that right there just so I don't have to like sign in the chat. No, I'm not doing that. I'm not chatting my own shit. Put that right there just so like I can't even see it. Wait, if it's not pulled up on the OBS, I won't be able to see. Can I put the OBS over here? Nah. Damn, I hate that. I need to get another monitor, bro. I've been streaming for. No, I'm not doing that. I'm not chanting my shit. I'm streaming for like an hour 50. Yes, 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 yes. Okay. That's fire. That's fire. Let me go ahead and put this right here. See, look, bro, if you want to be like, if you like want to get rid of that brain rot tendency, you're just like, bro, I'm too deep in, bro. I be on my phone too damn much, bro. Just come into the fucking live, bro. Come here, study with the bro. Come study with the bro. Fix your brain. Try to fucking de-rot your brain. All right, let's go. Define process scheduling. Okay, so these are objective. We can skip that. We don't need to see that. What is a process scheduler? Modern operating systems can run multiple processes at once due to concurrency and parallelism. I should have added more sugar to that fucking coffee. God damn, that shit is strong. This shit is strong. Fuck it, that's what I need. I need to wake up. This allows more efficient use of the computer. The scheduler must determine the order and timing of a process. Okay. So the scheduler determines the order and timing, the order of time. Of processes of P. Pushing P. What process runs next? How long it may run before allowing another process to run. The OS component deciding on the next process is called a scheduler. Originally, I was gonna do three. Like I was gonna do synchronization as well, but bro, I think I'm cooked. I think I'm gonna have to do that tomorrow. This is already like, it's already putting me out, bro. Like I'm already getting sleepy. Like I need to get better, bro. I don't know how some people can fucking study for like I sometimes I see people in the library, and I know I'm not. If I was listening to music or if I was watching a YouTube video, I might be able to like do it longer, just because I'll just take breaks, these small little breaks. But there'd be people sitting in the fucking library for hours just studying. I'm like, bro, how? How do you have the time and the patience to do that, bro? Like, you're actually built different, bro. Like, kudos to you, bro. Kudos to all those people who do that, because that shit is like, I'm trying to get to where you're at, bro. I'm trying to get to you, bro. I'm trying to get on that level, bro. I used to be able to do that too when I was in like high school. I would go to the library and just fucking sit there for just the whole day, just reading, putting notes down, doing all this shit. Now I can't even do that. Like, I think it's better to be at a library because right now I'm doing this at home. It's harder to study at home because there's just too many distractions. Like, I got my Xbox right here. I'm literally on my own personal computer. I could literally fucking look up whatever the fuck I want, do whatever the fuck I want. Nothing's really stopping me. Whereas at a library, you have those like limitations. You kind of have to just sit there and just actually lock in. But like, I don't know. I don't like the library at the campus near where I live. The schedule follows different policies when making this decision. Policies set by systems programmers. Oh, let me check Discord. Hold on. All right, no one's on. And config. The OS maintains a list of processes in the ready state. Ready to run, have met all the prerequisites to run on the CPU. Processes commonly alternate between ready and running. Okay. Throughput, turnaround. The number of processes completed within a unit of time. Then turnaround. Turnaround. Okay. So this is the turnarounds for individual processes. Includes both waiting time and execution. Okay. Damn, how many fucking slides do I got? 49. Yo, yo. Common scheduler objectives. Maximize the CPU utilization. Okay. Bro, I can't wait till that fucking. I can't wait till that Osart and Mike album drops, bro. That's just about to be so peak, bro. Like, man, bro, this is the year of like, just, just like soothing music, bro. That Iron and Wine album that dropped. my God, that shit just like that shit is for the soul, bro. That shit is there to heal the soul, bro. It's just so peaceful and just you just throw it on, you're just like just that at peace, bro. Like it's just so soothing, so melancholic, melancholy, melodic, not melodic, melancholy. Efficient use of the CPU increases system throughput. So, okay, that makes sense. That makes sense. Maximize the number of processes completed in a given time. So that's the throughput. This is the throughput. Okay. I'm just gonna put maximize throughput and not put that whole shit, bro. Minimize turnaround time. That's the amount of time it takes for a process to enter a new state and then terminate. Okay. Minimize the response time. This is the time between user input and the process response. Do, do, do. Oh, so these are all okay. So we're still continuing. They did say that they're gonna go into way more detail about this. Respect, process, priority. I did okay, so I do know about this. The fact that sometimes people prefer predictable response rather than faster response. Like they'll prefer that a process is predictable rather than it being faster, sometimes fast, sometimes slow, sometimes fast. They'd rather it be more consistent. Humans really just like patterns, I guess, bro. We really love patterns. I guess familiarity, balanced system load across multiple CPU cores. CPU or cores. Is that all the objectives or we still got some more? Okay. All right. Now that we can get into some actual meat. Short-term scheduler selects a process from the ready list and assigns a CPU core. Long-term scheduler selects which process should be brought into the ready queue. A medium-term scheduler selects processes to swap out of memory, frees up resources for higher priority processes, lowers the degree of multi-programming. So I'm pretty sure some of these some operating systems or some operating systems can have actually not even is scheduler the operating system or is that the CPU? Let me see. How do I get rid of this? I don't want this. I'm assuming it's the operating system. Okay, so it is the operating system. Okay. So the short term selects the process. Selects a process from the ready list and assigns a CPU core. So it selects the process. Whereas the long term selects like the basically makes the ready list. Selects which process should be brought into the ready queue. The medium. Selects a process to swap out of memory, frees up resources for higher priority process, lowers the degree of multi-programming. Priority processes. CPU utilization. Processes change state over their lifetime. Some require the process to be suspended. Reasons: waiting for resources, waiting for signals, advanced I/O operations, kernel operations, page faults. When suspended, the CPU can run another process. Okay. When we perform a context switch, copies of processors registers for the user process are stored in the process control block. Since we are in kernel mode and are not running the user task, where do we get these register values? Right, okay. When we perform a context switch, copies of processors. I'm not sure. I'm assuming. Okay. I don't know, but let's think about this. If we perform a context switch, I'm assuming we just get it from the process. You read the process, you're copying its state. I'm assuming it's either A or B. Assuming I'm just gonna go. Oh, I guess it's C then. I was off. I was gonna say I don't like. I didn't think it was gonna be B. I was really think it was, but like A just doesn't sound right. Ask the user process. Like it seems more like it's just gonna copy it. Like it's just copying it. It doesn't need to ask the user for the process, and I feel like it's already in kernel mode. So what's the point of performing a system call? Okay. How did these values get saved? Damn, I could have read that, but let's not. Okay. When a trap or error occurs, the CPU hardware automatically saves the user process register values before switching to kernel mode. Depending on the architecture, x86, the CPU pushes the register's instructions, pointer, stack pointer, flag switcher onto the kernel stack automatically before the interrupt handler runs. Some architectures have special dedicated registers that hold on to the saved states. So by the time the runs, the registers values are already sitting on the kernel stack waiting to be read and stored into the PCB. It would be A, right? Because the process already has them saved before the could always be the interrupt instruction swaps the pointer and pushes them. What the fuck, bro? I swear I just like, bro. Oh my god, I might fail this exam. The interrupt instruction swaps the stack pointer and pushes them. Before a process begins running, the OS sets a timer. Yeah, we know. Kernel, OS, and process address spaces are separate. Users cannot access kernel memory. Kernel can access user memory if it's still there. Why might it not be there? If it's not there, then that means it's probably like volatile memory. So like maybe a temp folder. So like it's not memory that's saved, but temporary memory or volatile memory. And if you like one, delete it, or two, the power goes out and it's gone, it's wiped. It may not be able to access it, or if you're trying to access memory that it doesn't exist, it might not be able to access it. I don't know. Interrupts transfer control from the user process to the kernel. The user process is suspended, and interrupt handler is run, handled like a separate program running within the kernel. The context, memory registers, it's different. We use context switch. We swap process context, content stored, the process, PCB. Process dispatch. Remove selected process from the ready queue. Okay, so we already went over this. A process may exhibit different resource usage patterns, and this can change over time, but is generally stable in the short duration the scheduler considers. CPU-bound process heavily utilize the CPU. They rarely perform I/O. They tend to use their entire quantum. I/O-bound processes perform frequent I/O operations. They read from write to relatively slow devices. This takes a long time and the CPU must wait. They do not tend to use their entire quantum. Burst cycles. Processes alternate between being CPU bound and IO bound. There are two regimes, characteristic behaviors of the system. Below is a graph of CPU burst duration versus frequency of the occurrence. So the lower the frequency, the lower the burst duration. CPU scheduling may be either primitive or non-primitive. Primitive systems will take the CPU away from a process. Okay, let me write that. Permission. Permission? Preemptive. I've been saying that. Preemptive. When this quantum has expired. Or when a higher scoring process needs CPU. Preemption has a lot of overhead. Okay. What is the best description of a process preemption? Taking the CPU away for one process and giving it to another. So, I mean, they all sound pretty good. Alright. To be honest, I think I might just finish the rest of this fucking tomorrow. Because this is a lot. And I'm already getting tired. So, I think I'm gonna end that stream.